So in this tutorial, I will basically show you how to use Maple to create and create tables, graph, and compute. So we'll start with the average rate of change and instantaneous rate of change lab. So first, recall that we discussed this in class, this particular slide here, okay? And let me go ahead and recreate this information in Maple. So first, in order to introduce a function, you would have to be in math. Then you type in f of t colon equal sign 16t squared, and notice that this colon here basically tells Maple not to compute until you are ready. So at this stage, if I remove the colon and click enter, uh, Maple will ask you to clarify that this is a function. So you go ahead and say function definition, meaning you're defining a function. Click OK, and notice that t is being mapped to 16t squared, which is our function in the slide for speed, correct? Now, if you want to evaluate the function at, let's say, 1, you just type in f. So you have to be in math once again. You type in f parentheses 1 close parentheses, remove the colon here, click enter, and it will compute f of 1, meaning Maple will compute f of 1. So here the average velocity is going to be a function of two variables, right, t and h. And the reason I'm writing it as two variables here is because h is going to be t will be at some point fixed, and h will be getting closer and closer and closer to the t value that we've meaning t plus h will be getting closer to the t value that we've chosen. So let me sort of just show you what I mean by that. So here at this stage, I've introduced average velocity in two variables. And once again, Maple asks if you're defining a function. You click OK because we are. And we get the following function. Now, if we let t equal 1 and h equal 1, then we can go ahead and compute the average velocity by just using this notation, v ave parentheses 1 comma 1, and it computes for us. If we change our h to 0.1, then we get this output. If we change it to 0.001, we would get this output, and if we change to 0.001, we would get this output. And notice these numbers are here. Okay, so the idea is to basically use Maple to do computation for you, but Maple is also very good with computing things faster. So what I mean by that is that you don't, in principle, have to pick h yourself. You can code it so that Maple computes the limit of this function here as h goes to 0. Okay, so we fix a t, let h go to 0, and we get values that we can use to numerically determine what the limit of the function is. Okay, so at this stage, let me go ahead and restart. Introduce that function one more time to make sure Maple recognizes that and nothing else. So now we go ahead and fix t to be 1, and we would get v of average velocity is now a function of just h. So let me go ahead and pick h to be 2 just to make sure that all the computations are being done correctly. So here we would have 64, which makes sense here. And now we want to plot this function f of t, which is our distance function. And this is what the plot of the function would look like, right? And we want to start with t equals 0. So let me go ahead and put 0. And notice that once I make adjustment to this code, I would only get this portion of the curve of the parabola. Now, why do we need that? Well, because time starts at 0, not negative 2. Now, here is the code for Maple that I was telling you about. Now, we can basically let h go to 0 by telling Maple for h from 1 by negative 0.01 to 0, do print v, meaning average velocity, 1 comma h, and end do. So what this code is basically going to be used for is computing the limit of our velocity, average velocity function here. Okay, so in order to get instantaneous velocity, what do? We take the limit as h goes to 0, right? So, and that's what we're basically doing with this code. Okay, so we're starting from h equaling 1, and then shaving off minus 0.01 each step until it gets to 0. And notice that at 0, this particular function would not be defined there, right? So the problem is that when h does reach 0, we will get an undefined output. But until h reaches 0, we should be getting outputs that are real numbers. So now notice that the minute I click enter here, Maple computes all of these values, and notice how quickly that was done. So if you sat down and tried to do this by hand, obviously it would take a long time. Now notice that we start with 48, and the numbers, as h gets closer to 0, the numbers are getting smaller and smaller and smaller, but at some point you start to recognize that as h goes to 0, your average velocity is going to 32.16000. Now notice that our average velocity output, when we chose h to be 0.001, we got 32.001 as the average velocity. So this number is meaning this is bigger than when we chose h to be 0.001. But the point that I'm trying to make with this code is that as h goes to 0, your average velocity is approaching a specific number, and it seems that it's approaching 32 in this case. Now, if you want to experiment a little bit, why don't you go ahead and change minus 0.001 to minus 0.0001 and see what ends up happening, right? And instinctively you should realize that you're going to get a lot more values than what we have here when we chose the increment to be 0.01. Okay, so those are the skills that you will need, meaning for the next lab you'll need to be able to introduce functions, evaluate functions, plot functions, and then eventually also create these output tables, okay, that we have here in order to analyze numerically limit of a function. Okay, so go ahead and learn how to code the things that I discussed in this video yourself by using Maple before next class. Okay.